What's up, guys, and welcome back to my channel. Just kidding. Okay. So today I'm gonna be doing homework 2, problem number 44, and the problem reads: charge Q2 in figure P25.44 is in static equilibrium. What is Q1? So I'm going to go ahead and draw the figure that they give us. Okay. So here we have Q1, and this end we have Q2, and gives us two distances. And right in the middle is a positive charge of 5 nanocoulombs. So I'm gonna go ahead and label this Q3 so they can all be labeled. Okay, so we know that Q2 is in static equilibrium. So given that Q2 is in static equilibrium, we have to find the point charge of Q1. Okay, so the first thing that I did was write down my knowns and unknowns. So we're given that Q3, this one I labeled, is 5 nanocoulombs, and in this problem we are trying to find what Q1 is. Okay, so we know that the equation for electric field is E times or equal to Coulomb constant K times the magnitude of point charge 1 times the magnitude of arbitrary point charge 2 over r squared, which is the distance between the charges. So, alright, since we know that Q2 is in static equilibrium, we know that the charges Q1 and Q3 acting on Q2 are going to equal 0. So, the electric field net charge is going to equal 0. So we have the electric field of Q1 plus Q3 equaling 0 of Q2. Okay, so then what we can do from here is break up this equation into two separate parts for point charge 1 and point charge 3. So how that looks is constant K times the magnitude of Q1 over R. I'm going to call this R sub 1, and this is squared, plus constant K of the magnitude of Q2 over R sub 3, my bad, 3 squared. So this is the magnitude of Q3, not Q2. Okay, and these both equal 0. Okay, and we can't forget what we're looking for. which is Q1. So that's this right here. So what I did next was I basically brought all of these over to the right side so that I could isolate Q1, and that came out to magnitude of Q3 times R sub 1 squared over R sub 3 squared. And since I brought this to so what I did here was I isolated my variable Q1 by bringing all of these variables to the right side of the equation. And you no longer see K because K was on both sides of the equation, so I was able to cancel those out. So we don't need to pay attention to those variables anymore. And basically the rest of the problem is just plugging in our given values and figuring out Q1. So I'm going to go ahead and do that. Okay, so we know that Q3 from our given is, I'm going to put in parentheses, is 5 nanocoulombs. And then our R value for R1, which correlates to Q1, is going to be 20 centimeters because that's the distance between Q2 and Q1. But we want to make sure it's in meters, and 20 centimeters is 0.2 meters, and that is squared over R sub 3, which correlates to Q3, and the distance from Q3 to Q2 is 10 centimeters, which is 0.1 meter squared. And then if you plug that into your calculator, you get 20 nanocoulombs. Okay, so after calculating that Q1, the magnitude of Q1 is 20 nanocoulombs, we have to keep in mind that this value is a magnitude of Q1. So we can look back up at our figure and see that Q3 is positive, and in order for this equation to work out, we know that the electric field for Q3 is going to be a positive number because of the positive point charge. We can infer that Q1 is negative. So then we get negative 20 nanocoulombs for Q1.